Well, hello from ATX West 2019. We're at the On Robot booth with Christian Hurlgard. Christian, would you give us an explanation of all of the end effector technologies you have showing?
Absolutely. We can start here. We got a few of our servo grippers. This is our standard line of gripper. The technology is, I wouldn't say basic, but it's a simple construction. We got a servo gripper with servo motor here that enables the user and the robot to grip different sizes, different shapes, but also different materials. So you have force feedback, meaning you can grip an egg, but you can also grip a piece of metal with the same gripper. So we have these two sizes, the RG2 and the RG6. If you want a bigger payload or have a larger product to grip.
And what kind of sensing technology allows such a range of gripping applications?
So, I mean, the sensing technology in the servo grippers are pretty simple. We just measure the current on the motor and then calculate the force. But we also have more sophisticated force torque technologies available. The 6-axis force torque sensor we can mount on any robot you want, and it will give you the 6-axis force torque feedback. And we actually took this product and paired it with the servo gripper, and now have the RGFT, which just launched here in January. And we're very excited about this product. We have 6-axis force torque sensors in each finger and a proximity sensor there. So there's a lot of sensing technology, a lot of feedback to the user when using this product.
And where is a typical application for this fancier gripper?
This would typically be a part insertion, like insertion task. It will be assembly. It would be different tasks where you have to have the force torque features, but still need the flexibility of gripping different parts.
That's super cool. And I hate to jump ahead, but I think that this new kind of gripper using van der Waals forces is really the fancy flagship gripping technology.
Yes. So we've developed the technology together with NASA because they wanted to pull solar panels out on the space station. So we took this technology that we developed for them and then turned it into an industrial gripper instead. So we call it the Gecko gripper because it basically uses the technology, or I wouldn't say technology, but the same method that a gecko grips onto a wall or to a surface.
This is using a whole different field of physics, really, for the effect. Would you demonstrate some? Yeah.
Basically, if you add force to an object, you create the adhesion. So as you can see, it's pretty stuck on there. But if you peel it off, you actually have an easier way of getting away. And that's the same way the gecko actually moves, by peeling off its fingers. So the way we release the parts is that we pull the pads into the gripper so that the frame will peel off the part that you're gripping.
That's the coolest thing ever. So what kind of workpieces would be gripped by this?
Glass, metals, plastics, acrylics, PCBs, anything like porous objects. But we do have a requirement to have a smooth and clean surface.
Oh, that's awesome. Well, thanks, Christian, for the quick explanation. Where should people come visit you? What's your booth number here?
This is 4481. And we welcome everybody. We have T-shirts and giveaways and everything we're handing out to our guests. So please drop by. We're here.
Thank you, and thank you for watching.